Hey, welcome back. Tonight we're going to be working on iterating on this design for the switches. I basically did a bit more work since last time I streamed. Very little though, just adjusted some dimensions and spent a bit of time printing stuff on the printer. I'll go over those changes before I start on anything else. And yeah, it should be a good time. I'm also going to go back on something I did last time on stream in Fusion 360. That was a bit of a hack. You saw me kind of like punch in a thousandth of a millimeter there to correct something that Fusion 360 was doing that was not quite to my liking. And as it turns out, it was actually my mistake, as these things frequently are. So I just want to go back and kind of explain what was going on there. Yeah, so without further ado, one of the first things I did after last stream was, so last time I printed this sort of two switch, actually, you know what, let me bring up this focus control for the C920. I think I can actually control the focus like this. Haha! All right, so this bracket, it's quite close. This bracket was like a two switch bracket that I printed last time, and it got me extremely jazzed about the prospect of printing out a full bracket for all the buttons and trying that in the keyboard. So that's the next thing I did, was print out this this bracket right here. Sorry, I'm still trying to get used to this focus control. So there you have it. It was this multiple switch bracket, and I put that in the keyboard, and it kind of felt great. It was really motivating. However, it wasn't quite exactly right. It was off by something like 0.5 millimeter on the total length, and as we'll see soon, I definitely need to redesign the way that these switches kind of fit into this thing. They need to be seated much deeper into the keyboard. The reason I'd kind of come up with this sort of just flat design at the very start was that that's kind of the way the original rubber dome switches worked. But unfortunately, I'm sure that in the version after having looked at my keyboard from and taken a lot of measurements, I'm pretty sure that they changed the inside of the version 2 of these keyboards, which had these switches mounted in by default. The switch really has to sit much deeper inside the keyboard than the original function dome switches. Rubber dome switches. So we'll be changing that design. I've started on that. You'll see that in Fusion 360 soon. And yeah, so you can see kind of here I've got like all these little spare parts. All these things are all tests that I made. I iterated just 1/4 millimeter here, 1/4 millimeter there, on designs and everything, and just got everything kind of dialed in right, such that the length would be okay, and these little ridges here, that we print, I kind of use them as registration features, so they fit within the keyboard. And they prevent the switch from the printed circuit board, what's eventually going to be a printed circuit board, from moving side to side inside the keyboard itself. And there you have it. All right, so that's it pretty much that I've done since last time on the switch mounts. Then another thing I've done, which I'll show here quickly, is to iterate on the design or rather the tolerances for the actual printed circuit board later on. So the idea here is that I've printed these pieces. I'll show them up close in a moment, and you can see that they've got these kind of like well, really what they are is isolation trenches, if you will. And what I've done really is I printed this design. I'll show what it looks like in Fusion 360 in a moment. What I did is I took this copper tape and I just stuck it on top. I basically put a layer on top here, and then I just pushed into it a little bit with my thumb so that I could see kind of the grooves. That's the word I was looking for earlier. Grooves. So I could see the grooves, just the outline of the grooves. And then I took a hobby knife, like an X-Acto, like this, and I just ran it down, right down the grooves. And the purpose of this is to basically cut the tape. The tape's adhesive is very strong. It doesn't move when you cut it, and the copper trace is actually pretty not trace. The tape is pretty thin, so it doesn't give much resistance. You can use it pretty easy. You can cut through it pretty easily. But the interesting thing with this that I was trying out is basically a variety of widths of grooves and a variety of depths of grooves. You can see here, this half here is a slightly shallower than this half here. And the reason for that is because what happens is when you cut the tape, the knife kind of pushes down into the tape and it separates it into the groove, and it creates an isolation there between these two traces. And I tried this in the past for another project with Halloween, and it actually turned out great. This time I have a bunch of ideas to kind of simplify the process and the design. I also only have a single-sided PCB to do this time, so it's going to be much simpler. Or I hope. There's a few sort of constraints that come with working inside the keyboard and stuff like that. But what's good about this is that pretty much every single test, every single trace on these boards here, and there's what, like I think two dozen or more, they all turned out great. I mean, cosmetically speaking, some look better than others, but functionally they're all the same. All the isolation worked properly. So it seems like I have quite a bit of leeway there with these tolerances that I can play around with when designing the final PCB. One thing that I'll have to worry about actually is if you look at this bracket, let me take control of the focus once again, but if you look at this bracket here, what happens is the switch sticks out through the bottom of the bracket like that. You can see the plastic pins here, they stick out, and you can see the metal pins as well. Now these metal pins here, here and on this side here, these are the pins that I need to solder to. When you close the switch, these are the pins that are going to actually close the circuit. But as you can see, the pins are not super long. I think that this actual, if I'm not mistaken, I'm not actually sure the depth of this mounting plate that I printed there. I initially thought it was like 0.5 millimeter, but now that I look at it, I think it's a bit more than that. Let me just measure that quickly. It is actually 1 millimeter. So that's good. That means that I have a bit of leeway here. Actually, I'm less worried now that I have 1 millimeter. I probably have another millimeter or so that sticks out. So 1 millimeter is more than enough for the thickness of the PCB. But I'll have to think about how to print this, because I obtained the best results when there we go. I obtain the best results when the isolation traces are on the top side of what's being printed. If this stuff is on the underside, then what happens is the first layer of a 3D printer, you have this problem, I guess, quotes, with any printer, but the first layer is it has to be squashed a little bit into the print bed for the adhesion to be good. Otherwise the print just comes off the bed when the printer works. And so what that happens is it creates this phenomenon called elephant's feet. Now it's only called elephant's feet really if it's super pronounced, if you really wind up with like this sort of like flattened shape because everything was squished so hard into the plate. But even if you dial it perfectly, you still kind of want this like smoosh on the first layer, so that everything sticks properly. And of course that affects the width of the isolation trace here of the what's the word, the groove, the isolation groove here, I should say, of the groove basically. So and it makes the kind of running the knife down it a little more uneven, and I suspect what it would do is it would make the whole process a little less reliable, which obviously we don't want. I mean, it's not like an incredible amount of traces here, but I'd love to figure this out so that it was kind of a more generic method for people to work with, I guess, very short production runs, prototype runs rather, in the future. Because I actually think this is quite convenient to work with. And I'm also going to try to work out some kind of a workflow on the Fusion 360 side, such that it's actually easy to sorry, I just realized I wasn't recording there. Such that it's actually easy to work with this in Fusion 360 as well, to create the isolation grooves and everything. So without further ado, let's go back to the desktop for a minute. I'll show you the work I've done in Fusion 360 since last week. All right, so we're back to the desktop. Oh, hey, Daru. Thanks for joining. All right, so what I wanted to show last time is this old version of the PCB that I had. It looked a little like this. You've seen me print this. Obviously these ridges, these registration ridges, are a little deeper than they were last time, just things that I tried out. But one of the things you'd seen me do is here, when I was looping, or rather repeating, mirroring these things over, I was trying to do this join operation, and it wasn't joining up quite right. And so what you saw me do here, kind of sucked, was here in this distance field, I'd subtracted just a smidgen, just a little iota here, so that it would force the bodies to overlap, and then the combine operation worked. Now I kind of glossed over that in the video because I wasn't 100% sure what was going on, and I made a mental note to come back to it, which obviously I did, but I didn't want to spend like, you know, an hour just kind of digging into it and trying to understand what was wrong. Now, as it turns out, what was wrong was the fact that here with the PCB, the sketch rather, I basically had two lines here on the right side, two overlapping lines that looked like they were exactly in the same place, and they were, but they were both driven by separate dimensions. They were driven by separate mathematical equations. And what happened was, because of this, even though the lines were physically overlapping, it actually created you see how here I mouse over this? This is called a profile. Could also be called, I guess, a region. It's an enclosed area of the 2D drawing that you then extrude. Now, when I say extrude, what I mean is I'm talking about this. This is the first part that I extruded here. And if you look at this, basically you select which of the profiles here you're going to extrude. Now, it turns out that there was this extra invisible profile here along this edge where there was my duplicate line, and that profile had not been selected for extrusion. And so what was happening was there was effectively this infinitesimal gap on this side here, and when I was repeating the design over and over, this gap was effectively preventing the bodies from joining up. And so the reason this became apparent eventually is because I was playing around with this parameter here, which was basically the key tray width. Now, if I make this extreme, you can see that it widens it, right? Like the width becomes everything, all the dimensions are kind of keyed and programmed properly. But because my profile hadn't been selected, I saw this gap show up here, this big, tremendous gap. And I was like, aha! So there's something there that I'm not extruding properly. I went back and I saw now the actual profile was showing up, the missing profile was showing up in the sketch. And I was able to select that for extrusion, and it fixed all my problems. So I'm going to undo this. This was my original version of the PCB. I kind of moved away from this design for a couple of reasons, but one of them is really important. So you can see here what I was trying to do was, if I mount the switch here inside this bucket here, the switch would be facing upwards. So I'm going to sit properly in my chair so you can see my face when I talk. The switch was mounted upwards, and this part here, these kind of ridges, they were used as registration features, so they would sit inside the keyboard. There's a kind of a grid inside the keyboard, and these would fit perfectly inside this grid. Now, originally I pointed out last episode that I realized that the switches needed to be mounted even deeper, so instead of mounting them as close to the faceplate as I could, I tried to make these ridges thicker, right? So that, or taller, I guess, so that they would rest against the front plate of the keyboard. I'll show that on the other camera in a minute. But the problem here is that though the grid, I'll show exactly what I mean there, but the grid here against which the flat plate rests is completely flat. These ridges, they rested against the actual front of the keyboard, which you may remember is actually quite curved. It's curvy. So what was happening was, on this side, for example, well, you know, these were kind of bumping against the faceplate, and the switch was mounted at the right depth. And then as you moved over inside the keyboard, there was all these curves in the faceplate, and it was actually putting the switches at variable depths inside the keyboard. Not only that, but they wouldn't actually, because there was a curve, the full length of the ridge would not rest properly on the faceplate, which is incorrect. So let me go back to the other camera for a sec, just to show you exactly what I meant. So let me take over the computer again here. You can see here, this is what I was talking about earlier. I'm not sure whether I should actually just manual focus this. Let me try that. Let me try to manual focus for a second. All right. Is this too much? It is too much. Style that back out for a bit. All right. So you can see these this kind of grid here around each hole for the keys. Now this is where the ridges that I showed earlier would wind up registering properly. So you can see these ridges quite well on this print. You can see the ridges there. So if I fit the piece inside the keyboard, it fits nicely and it doesn't move left to right because the ridges, they fit inside the grid. Now obviously it moves a little bit on this side. This is something I fixed in ulterior designs, but it doesn't move sideways much, if at all. However, if you go and you make these ridges thicker, what happens is instead of resting against, let me see if I tilt this. Yeah, there you go. So instead of resting against these little ridges here, it rested against the actual inside of this part here, the very underside of the faceplate, which I don't know if I can tilt it enough to show you. It's kind of hard to see, but the grid at the top is completely flat. But maybe if I show it like this, actually, or maybe like this. There you go. You can kind of see how this part, this top part here, is super flat, but you can see how the inside of the grid is quite curved, and you can see how the profile you can see the profile here varies quite a bit. So these ridges were trying to rest against the faceplate, but obviously in this hole they were much deeply seated than in this one over here where it's quite shallow. So that's not correct. So what I had to do was go back to the drawing board. And then what I did is I printed more something like this. Well, this actually was my test with the super deep ridges there. There you go. But the latest prototype that I have looks a little more like this. Let me set down the keyboard for a minute. It's the one that I showed earlier. I can actually crank up the zoom just a little bit for this. Whoops. There we go. And so from the side, what this looks like is quite different, right? The registration ridges are still there. They're very small though, but these are actually thick enough to actually fit inside the keyboard and not move. I am going to make them a little thicker in my next design. I think this is something like 0.2 millimeters, or maybe it's not a lot. I'm not even going to try to measure it. And I make it a bit thicker, and you can see how there's this deep groove here. There's like this box, this seat almost for the switch. That allows the switch to sit much deeper inside the keyboard. And the idea is for these flat parts here around the grooves. So you know what? I should grab something to point. There we go. So this flat part here. Whoops, sorry about that. This flat part here and the flat part that's around the ridge here, it's very small, but there is actually a lip around this ridge here. These are going to rest against that flat frame inside the keyboard. But even this is not quite right. I was kind of playing around with this earlier. It's getting there, but there's a few sort of issues there. And the reason for that is actually I'm on the right track. It's just that when you look at inside of the keyboard, what happens is you've got these other things that are starting to come into play now. You've got these little ridges here, here, and here. I believe these are known as ribs in industrial parlance. There's also these nubbins here, that's a technical term, that used to hold down the original PCB. Now, anybody who wants to kind of replicate this modification is, unfortunately, I hope this is the only modification you have to make to your keyboard, other than soldering these connectors. Eventually this connector here is going to have to probably go away because it's going to be easier to solder to the pins directly than to reuse the original ribbon connector. But you have to cut these little plastic nubbins off. But you have to do that the first time you run into problems with your function switch. As soon as you want to get inside the function switch assembly, it's the only thing that is irreversibly assembled inside the keyboard, meaning that it's not screwed down, and you can't just trivially take it apart and then put it back together exactly the same way it was. This is actually, there's a plate there, a plastic plate, and then there's a bunch of hot glue. Or sorry, it's not hot glue. What they do is they put the plate through these plastic things and they melt the plastic. They melt it down above the plastic plate, and it holds it in place very securely. Now, as soon as you want to get in there, you have to cut these away. I used a very sharp knife the first time. That allowed me to extract the plastic backing board there for the PCB, and then I just hot glued it back in place, which was more than enough to hold everything in place. And as it turns out here, if you look inside the keyboard, for us, obviously, I'm going to try to not rely on the shape of these nubbins, because if you cut them off completely, then this should still work. But what I'll probably do is I'll make it so that my design kind of rests on the underside of this bit here. Even though it wiggles a little bit, this actually rests against the bottom of the keyboard here. There are these plastic prongs here that rest against the bottom faceplate, so when the keyboard's closed, it doesn't move at all. And I might actually try to exploit this this screw hole here, which interestingly enough does not appear to be used in my version of the keyboard. It appears to be quite blank. I can see that it's been, I think it's tapped actually even, I'm not sure. But there's certainly no screw that goes there on my keyboard. And I'm not sure what it was for. Maybe it's for another design, another revision of this keyboard. I'm not 100% sure, a leftover. But in any case, it suits my purposes quite well. So, yeah, there you have it. What happens with this this bucket prototype here, let's call it the box or bucket prototype. I'm going to switch back to autofocus for it. Well, maybe not. Is that when you fit it in, well, first of all, it's a little too long. I think I got my tolerances wrong. It doesn't quite sit super well in there. It actually moves still a little bit. Well, is that right? Yeah, it moves a little bit. That's actually not too bad. Here's, you see, I'm kind of cheating. I'm using a hole that doesn't have one of these plastic ribs in the way, so it has nothing in the way. It's one of the best key holes to use. On the other hand, if I try to push down on the switch on the key, it's not quite right. It doesn't quite exactly line up with, oh, does it work? Yeah, it kind of does actually. It does line up with the hole. Can't see this, sorry. Let me see if I can flip that around. I have to hold 1,000 things with my hands there. There we go. Let me switch back to autofocus for a minute. I think that'll work this time around. That was this hole. This actually looks like it's about the right depth for mounting as well. I'm gonna have to make these switch keycaps a little smaller, even because I can hear it rubbing against the side of the keyboard. It's pretty tight. I mean these are going to be lined up pretty well there, but this is pretty tight. Okay. Now, yeah, if I line up the back side really properly, then the front side doesn't work anymore. So the switch is a little too high in the bucket, so I'll have to change that just a little. It's like a smidgen. It's a very, very, very small amount, like not more than, I think it's like 0.5 millimeter or something. Oh, there, we lost the switch. So move the switch down a little bit. I'll do that in Fusion 360. Do I need to do much else actually? I mean, this thicker part here, I won't bother to focus, sorry. This thicker part here at the bottom is going to help with the rigidity of the whole design, because I'm probably gonna have to make the bottom part a little weaker, actually a little thinner. I'll make the ridges a little thicker as well. And I'll have to figure something out for these ridges here. Oops. To make sure that I don't run afoul of these ridges here. So, does it actually fit in there? Yeah, it doesn't even really fit inside the hole because the rib is protruding too much. Yeah, okay, so, okay, well, if I move the switch down a little bit in this design, it gives me a little leeway to maybe kind of chamfer this edge or something to try to get rid of the rib. So let's do that. Let's go back to the other station for a sec and start a print. And then probably what I'm going to do is I'm going to start on the PCB design. All right. What's going on here? I've lost my music. All right, well, that's sad. Oh well. All right. So let's close this. I don't need to, no, don't save, blah, blah, blah. It's my PCB trace test, my keycap. Probably make the keycaps a little smaller even. All right, so we said the ridges need to be a little bit thicker. Oops, sorry about that. What's the distance here right now? It's 0.5 millimeters. It's quite a bit. I thought it was a bit less than that. All right, now if I select this, so let's bump it up a little more. I say 0.8 millimeters. And then we said we wanted to move the switch down into this by about 0.5 millimeter. So the dimension for that, this is here. It's at 0.5 millimeter, right? So that'd be 2.2. But that moves the ball. I got this keyed wrong. Okay, wait. This is not correct. Okay, what I need to do instead of driving, what's going on here? This is between this line and this dimension here. So I'm going to get rid of this dimension here. I am going to instead dimension from here to here, which I know would be good. Okay, 1.27. So now, if I move this guy down, all right, the bottom ridge doesn't move, which is good. All right, and the box moves. All right, that's good. That's good. All right, so 0.5 millimeter. And then I said I was going to try to do something about the chamfering here. So let's suppress this for now. Should I chamfer before or after the depth? Probably before. Okay. And then let us chamfer this. Yeah, see, I don't want to chamfer too much because it's gonna, or maybe a draft. I don't want to weaken it too much. That's the thing, right? Well, it looks like I can actually do a little bit more. Maybe like 1.5 millimeters. There we go. And if I, all right. Actually, sorry. This no music thing is driving me mad. Let's figure out what's going on here. Will Winamp work? It does. So what's going on with Plex? Is it somehow dead? No, there we go. All right. All right, the music is back. Sorry for this brief interruption. All right, so I think this looks promising. Now, if I unsuppress, this feature is just to do one at a time, right? I don't want to mess around with, I don't want to have to print the full thing, though I could actually print two to make sure that the registration still works properly. Okay, so I'll print 2. Like that. Alright. This doesn't look too bad. Oops. Oh, sorry, that was a miscued command. See, this is a 45-degree overhang as well. Printers typically, like a good printer, yeah, welcome back, Daru. A printer will typically print up to 45 is pretty safe. 45-degree overhang, meaning that this is going to be flat on the ground and it's going to print like this in a basically rising slope above nothing. But if you go up to like 50 or 55, then you're starting to get into like wobbly land. But really good printers will do like up to like 60. I think some printers even do like 70 or something like that with reasonable results. Now mine, I've never really tested it. I've never done an overhang test. I know it handles 45. I think for even 55 it'll do properly. So 45 should be good. All right. Is this good enough? Yeah, let's try that. All right. So let's export that to the PCB. I just keep overriding the same file. Don't really care. The old designs aren't any good anyways. PCB. This is the slicing software that I use to prepare it for the printer. And then I'm going to prepare this. I'm going to prepare the printer, make sure the printer's on. And victory. Just check to make sure that it actually showed up properly. Because it's, there we go. Alright, that's good. Now let's back to Octoprint. And so let's reconnect to the printer. There we go. Let us set the temperatures for preheat so that we save a bit of time there. I'm gonna go and that's not right. Was it saying 21 minutes? What if I... Nah, it's not going to make much of a difference. Oh, this would make a difference, though. If I actually print it twice as thick, the quality will go down, but who cares? For this, normally for the final print, I'll print it at 0.1 or even 0.05. For just dimensional prototypes and stuff like that, it's not worth it here. I mean, some of the finer details, maybe I'll get less detail out of, but I've run a couple tests at 0.02 before, at 0.2, sorry, and it was fine. So let's try this then. So 12 minutes, that's decent. Let's save this over at the G code. Then let's upload this. So what I'm doing now is I'm uploading this to Octoprint, which is still running on this PC. And I'm going to print. So now it's estimating good 12 minutes, but the bed's already heated up. So now it's just basically trying to get the red line here is for the tool, so the extruder number 1 on my printer, which I only have one extruder, so that's totally fine. It's basically the bit that prints the plastic. So I can actually set up the camera here just so you see what's going on. All right. It won't make much noise. It'll be less pronounced a bit later on. You can actually, what's cool here with Octoprint is because it's actually driving the printer. Let me turn the webcam down a little bit. I actually just tend to slouch in my chair. I know it's not good, but there we go. So it's actually going to visualize what's going on in real time. Now, what's happening right now is it's actually performing what's called the homing sequence. It's going to actually now it's done the homing sequence. So there you go. It's printing what's called the skirt, which basically is just used to prime the extruder, make sure the plastic's flowing properly. I can see on the camera that it is. There we go. So you'll see the little pieces of plastic come out very soon. In fact, if I do a quick, there you go. Whoa, what was that? Oh, that was weird. What happened there? I see the fan snapped off. Still looks all right. I'll have to check what's going on here afterwards. All right. Never a dull moment. Never a dull moment with a printer. All right. So what we're going to do now is I'm going to start working on this PCB design. So the underside of the switch tray here is going to have a PCB. Basically, it's going to have traces and stuff. But I'm going to need to replicate what's going on with the original PCBs here. These flexible things that I showed on camera last time. Now, I'm wondering which one I should start with. I've kind of been iterating on the right side of the keyboard, which when you're looking at the inside of the keyboard is kind of on the left side. So let me just make sure that I've got the right one here. So I'm not showing this on camera, but it's fine. I'm just trying to figure out which ribbon is which. All right, so the one I've been iterating on is this one, our lucky winner. All right, so I've got to replicate this design. Now, as it turns out, this actually turns out to be the more complicated one. The other one appears to be a little simpler. They're not symmetrical for some reason. And I'm just gonna stare at this for a minute to see what's going on here. Okay, so okay. Okay, let me switch back to the other desk and I'll kind of outline what I'm doing here. Let me point the camera down a little bit so I can see what I'm doing here. So, what's going on with this thing is that, let me turn the focus manually again, like this maybe. As you can see here, that there's a series of black parts. These parts are the parts that the rubber dome initially just pushed into. And you may recall that I'd explained that basically there's a graphite pad. These are conductive, and there's a graphite pad on the bottom of the rubber dome. And as it makes contact with these, it closes the circuit. Basically, it allows the current to flow from one of these black parts to the other. And what happens here is these white parts are effectively flexible circuits. They're traces that are also conductive. And you can see that there's a pattern here, basically. Some of them are shared. So this, for example, this bottom trace here is shared between these two black pads here. And I'll explain why that is in a moment, but you can see that the pattern kind of repeats further down here. You can see that this trace here, there's kind of this like H shape. It's shared between these two buttons here. And it's also shared with this button here. And then this button, yeah, this button has its own thing. And then there's this another one that's shared here between all three. If I try to point at this again, maybe using the knife, that'll make it clear. But there you go. This guy and this guy, if you follow this down here, it also connects to this as well. So what this means is, if you think about the way these are organized, logically speaking, I'm not going to go through like the whole theory of like how to build a switch matrix here, but generally the way these things are built is they're actually built as a grid, and you've got basically a certain number of rows and you've got a certain number of columns. Now that has nothing to do with the actual physical layout of the switches. It has everything to do with the electrical or logical layout of the switches, and that's exactly what we're seeing here. So what happens is it's basically a way to multiplex or connect multiple switches to a few input lines on the microcontroller. Turns out that if you're doing this kind of the simple way, you only, and this is how it's done here, you only need as many, like if you have, for example, I don't know, whatever, 4 rows and 4 columns, that means you need 8 pins on the microcontroller. So number of rows plus number of columns. But you actually get 4 times 4, so 4 rows times 4 columns as a number of switches that you can read from the microcontroller. So that's what they've done here. In order to minimize the number of pins that they required probably on the microcontroller, and also the number of traces on this ribbon, they arranged these in a logical grid. Now, I don't know what how they've envisioned these internally. I'm like swinging this knife around here. I gotta be careful not to gouge out my eye. But you can see that these two form an arrangement, as we saw earlier. These 3 also share a lead, and these 3 also share a lead. So you can picture that as being sort of, a row of 3 switches, another row of 3 switches, and a row of 2 switches. Now, if you look at the other leads here, you basically have got, clearly, you've got one trace here on this side that is actually it goes all the way to the end, at the end of the ribbon. You can't see this is off camera there, but it's straight all the way to the end. This guy here also has his own trace, so it's not quite its own column. It's kind of weird. It's kind of a halfway design. However, I think the other ones do actually share stuff. Now this button has 2 completely dedicated traces. They don't. Is that right? Is that correct? Yes, this button has completely dedicated traces. It doesn't share the traces with any other button in here. This is a really weird design. This has its own trace. So yeah, it's unclear what they did here. It's possible they actually reserve a pin for each of the buttons, but what they just did was they replicate ground maybe across all the buttons. It's hard to say. No, I'm sure that design would have been super. Anyways, I don't have to second guess what they've done or how they built it. I just have to replicate it. That doesn't really matter. So here, this guy has its own trace here. I'm trying to keep this in focus, but it's not easy. This guy has its own trace. This guy has a trace that actually winds all the way around here. This is the most complicated trace, I think, on all the boards that I have. This one. Oh, wait. This one is shared with this one. Okay. So there is a bit of a column arrangement going. It's kind of this hybrid thing. There is a row and a column thing going on, but not on all buttons. This one is not shared. This one is shared, as we know. This one also goes around and wraps around. Yay. This is shared. Ooh, and this one. Okay, I just need to like really look at this from up close for a minute there. All right. Okay, it is shared. Okay, so what I'm gonna do, I'm going to draw this out, but I could just replicate the design blindly in Fusion 360. Let me just check on the print 1 second. It's about 85% done. About 85% done. So it should be done soon. So what I'm going to do is I'm actually going to map this out by hand with a pencil on a piece of paper. Just looking for paper over here. All right. Kind of improvising here. By the way, I love this clipboard. I got it at a like environmental object store in Ottawa called Arbor Recycled Products, 800 Bank, and that's the address. And it's an old motherboard from what is clearly a large machine. I don't know what it was initially, and I've had this since I think, I say 1995 or 96, and it's still in perfect shape. I really love it. Well, perfect. I mean, it's been banged up a little bit here, this part, but it's actually really high quality design, and I love it. All right. So let me just check quickly. See, so even here, like the ends of these ribbons here, they don't actually have the same number of traces. Do they have the same number? Not even. They don't even have. They have the same number of buttons, different number of traces. Oh, somebody's chatting with me. Something. Sorry. Looks suspiciously familiar. Could I take a picture and use that in Fusion? Yes. So I could take a picture. That's certainly a very, very good idea. I could trace it out with, say, paint.net or something. I could color them. I'm going to do that. That's a great idea. Thank you for the suggestion, Daru. I'm not 100% sure I want to actually use it in Fusion, other than maybe just as a reference or something like that. Because my layout's obviously not going to have the exact same dimensions. What I meant is I could actually go and like trace this, for example, run it through a vectorization program, trace it, and then extrude it or something, and actually like physically reproduce the same circuit. But in my case, I don't think I can go that far because, yeah, the layout doesn't match exactly. However, taking a picture is a great idea, and I'm going to show you why in a minute. Let me take out my phone. So H.R. Keane says it looks suspiciously familiar. I'm not sure. Oh yes, he's talking. H.R. Keane is a good friend of mine from university. He's seen this. I carried this in university, so he recognizes it. He has a good memory. So I'm going to take a quick picture of this printed circuit board. Actually, if I try to flatten it out, maybe my fingers. I wonder if it'd actually help if I had a. I'm try with the flash just for giggles. And the other thing that we're not going to say on screen. It's a bit intense. Let me see if I can. All right. Ooh, the print is done. All right, so that's good. So while I let my phone upload these pictures, it was in flight mode, so I wouldn't get disturbed during the stream. I'm gonna have to take it off flight mode to see what's going on here. All right, so let me just make sure Google Backup's gonna do its thing there. Shouldn't be very long. Just connecting to Wi-Fi. Derp, derp, derp. Oh, it's backing up. All right, I'm gonna let it do its thing. And in the meantime, we can take the print off the print bed and see how it turned out. I'm doing that right now. There we go. All right, this doesn't look half bad, if I may say so myself. Let me put the printed circuit board back on my desk. Make a little space on the desk there. All right, now there we go. This came out nice. The ridges are all well defined. Switch is clearly a little lower seated. Let's see what's going on if I take one of these switches and I put it in there. Has a great tactile feel. The switch is well seated. Can you see that? Sort of, yeah. There you go. Well seated. Let's see how it fits in the keyboard. Let me pull down the focus a little bit to get a little more maneuvering room. There we go. So actually I should have probably, you know what, let me put in 2 switches. Can I fit 2 here? Oh yeah, that's right, I've got the chamfer. Ah, look at this. The chamfer turned out nice. Very cool. Let's see if it actually fits in there before I do anything else. Oh, this looks promising. Quite promising, in fact. Okay, so the switch is still not exactly in the right place, but that's fine. We can correct that. We can iterate on that. Keycap fell off. I've got so many of these keycaps here. Some of them have slightly different sizes than the others. I mean, you know, tenths of millimeters. I think these are the smaller ones. I'll move the other ones out of the way. There we go. And fit this other switch here. There we go. Is that okay? Yeah, that is okay. All right. Now, will it blend? Will it fit in the keyboard? Oh, okay, this I can see going somewhere. Okay, so it fits nicely. It kind of locks in place there. But the switch is still not exactly in the right place. Well, so the next thing I think I need to do is print some slightly smaller keycaps, because these are clearly too big for these holes. So let me get on that right away. Okay. All right. So let's go back to the keycap. Let us, oops, what's going on here? Let's look at the hole tolerance, which I believe is actually used in the original sketch. Yeah, so the hole tolerance is this dimension here, hole tall, hole tall, hole tall. So this is the size of the hole, which I think is about right. Not 100% sure, but I think it's about right. And then what I do is I've been actually increasing this hole tolerance a little bit. Let me just bump this up, you know. If I bump it up, and it's used on both sides, right? So if I want to shave like not a millimeter, but say 0.8 millimeters, it's a bit extreme. Let us see, 0.6 millimeters, that would be an extra 0.3 on each side, so 0.7. See how that made it simpler, or smaller I should say. Stop the sketch, go back to this here. I started actually printing these upside down just for now to, you know what, I can actually even suppress this feature, whatever, so that it, so I don't have to clean up the feet. I'll probably switch it back eventually, but just what's going on? Oh, these are the lettering, okay. So let me save this. So you see, I try to always kind of have both things going on, like a print going on while I iterate on other stuff. Keycap here, get rid of this slice. All right. Let me rotate this out of the way like that. Let me multiply it. Let's print, say, 3. All right, 3. All right. And then let's move this back. Like this. And 0.3, you know, I can probably, I think with the switches, the keycaps, I can get away with 0.3, which is quite a bit, but it's going to save some time, which means more iteration. So 6 minutes for 3 keycaps, that looks good. I like those odds. And back to Octoprint. Trash this old one. 8 keycap, 837, looks right. Temperature, let me preheat. Because I'll explain why in a second, why this preheat step is fun. Is because what happens is in the G code, which is the text basically that the printer interprets, there's 2 sequential commands. There are 2 types of commands for setting temperature. There's one that's just set the temperature and keep going, and the other one is set the temperature and wait for it to be reached. Now what happens is Cura, the software, this software here that I use, the startup sequence is always fixed, and so what it does is it inserts first a command to heat the bed and wait, which is usually kind of long, and then heat the extruder and wait, which is also kind of long. Now what I would love to do, and I probably will maybe get around to do it at one point, is first when you set in Cura, when you set the temperature for the material down here, the first thing I would do is I would basically issue 2 commands that say, you know, set temperature and don't wait, set temperature and don't wait, and then go back to the first one, set the same temperature again, but wait this time. So you basically start heating up, both at the same time, and then you basically just block until both are at the right temperature. I can do this by hand. I can edit the G-code by hand and get it done by hand, but it's kind of long and I don't do it every time. My sort of workaround is this manual workaround where I basically issue 2 commands by hand to preheat, and then the first one basically just waits for the bed to be heated, but while the bed is heating, which normally takes some time, the extruder is already trying to reach the temperature, which saves some time. Actually, on a short print like this, you know, this printer can take up to like, I don't know, 2 or 3 minutes maybe even to heat both up completely. So it adds quite a bit. If you're printing for 6 minutes, this is adding like 50% to the print time, which is long. So yeah, you could write like a Cura plugin to do that for you. They're very, very simple. They're Python plugins, but I haven't looked into it yet. Now let's see if the phone uploaded the pictures. It says it did. All right, there we go. We've got a couple pictures there. This is good. Did I have anything else to check on the original bracket before I get back to this? You know what? I'll wait until the keycaps are printed. Let me just check quickly there. Okay, I see. Alright. I can see that there's a bit of plastic stuck on my fan shroud, which is no good. But we'll have to do. So this actually doesn't look like a half bad picture. Let's try to find one that's in focus, and this doesn't look bad. This doesn't look bad either. Alright, these flash ones are crap. This best one. This looks like the best one. Let's download this. I'm going to put this with the rest of the documents, which is not quite the right place, but all right. There we go. So time for some another type of, whoa, what's going on here? Another type of making. Let's open this. Now let us rotate the picture. Oops. Like this, and then crop it. Okay, so I wonder if I can actually do a bit of a contrast job here, or whether I'm not even sure I need to do that, to tell you the truth. All right, so I created a new layer here. I'm going to use the fill bucket tool. I'm going to tell it to sample the image, and I'm going to try to, that's not quite right. All right, let's actually, so I click here and then bring the tolerance down. Yeesh. Yeah. Okay, I see what's going on here. Okay, so can I? So this is going to be useful. Can I contrast this? Oops, it's doing just a layer. Let me try to. Yeah, see this area here, around this here, winds up blown out because, and these are super dark. So what I've done for this in the past is, this is kind of long. I don't know if I'm gonna set this up again. I can't actually even remember how I did it. But what I do is I change the blending layer for this. I'm gonna create a big brush like this, paint this white, say, and then here I'm gonna change the blending mode. Additive, nope. Burn, dodge, nope. These are extreme, reflect, glow, neither, overlay. See, I'm kind of just messing around here to see if I can actually. So I've done this for to adjust, draw black lines there. Yeah, I could draw black lines. I totally could. What I'd done for another. Oh, I remember. I remember what I'd done. Okay, check it out. Okay, what you do is you duplicate this layer. Now I adjust both separately. So I'll adjust one so that this area of the picture looks good, and I'll adjust the other one so that this area of the picture looks good. And what I do is I set up another layer that I'm going to multiply, though I'm not sure whether that works with the alpha channel. I think I have to kind of bake it in. And then what it does is allow separate parts of the picture to show up. Actually, you know what? Before I even get into this, let me try something really quickly. I could actually, if I went into this. Oops, it's wrong. If I did this, increase the tolerance just a little bit so it doesn't bleed, right? And then I go like this, and I just keep doing it by hand like this. Is that correct? Yeah, I turn the tolerance down a little bit, just a little bit. Suppose I could do that. That'd be kind of long. Let me just for a minute, let me look at this other method I was thinking of. Okay, so contrast is looking good. I'll probably do what you suggested exactly, which is to manually draw some stuff here. Oh, I got a problem with my sound card. Ooh. I hope this is not going to affect OBS. Alright, trying something here. Alright, I look like I still have sound. Oh man. OBS is using the card, so I can't rejigger it. I have a problem. I think the sound from the microphone is not going to work anymore. I might actually have to stop streaming here for like 30 seconds just while I fix this problem with my sound card. That's really unfortunate. I will be back. Sorry, in 30 seconds. Sorry about that. I got to stop for a minute there. I'll be right back.